Okay, welcome to part 2 of our transformation lesson. In this video, we're going to talk about vertical and horizontal stretch and shrink. Okay, so let's first begin with vertical. Okay, a little definition. If we want to do a vertical, it's going to look like this. Y equals C times your f of x, whatever your function is. Okay, this will indicate a stretch. If the absolute value of that constant, that C value, is greater than 1, it will indicate a shrink if the absolute value of that constant is less than 1. Okay, so really that's going to look like 0, excuse me, sorry about that, 0 is less than C is less than 1. So it's kind of between 0 and 1. All right, you would have stretch, shrink, make sure I got my notes, I have my hand in the right place. Greater than 1 I got, less than 1 we've got. Okay, stretch, shrink. Okay, if we do horizontal, okay, then your function is going to look like this. You're going to take an f of x over c, whatever your constant is. Okay, and if that's the case, we're going to end up with a stretch if its absolute value of c is greater than 1, and you're going to end up with a shrink if the absolute value of c is less than 1. And then again, 0 less than c less than 1. So you're between 0 and 1. We can't be negative. All right, so let's do a little example. Let's suppose that f of x is equal to x to the third minus 6, not 116x, that'd be pretty crazy, okay, is minus 16x. Okay, so let's mess around here with your equation. All right, so let's say that first I would like you to do a vertical stretch by a factor of 3. Okay, so vertical stretch, factor of 3. So vertical stretch means the c is going to sit in the out front of that function. So your f of x is going to become 3 times x to the third minus 16x. Okay? And yes, you could go ahead and expand it from there. Secondly, let's try a horizontal shrink by a half. Okay? Try a horizontal shrink by a half. All right, so f of x will become, so we want a horizontal shrink because it's less than 1, our factor here, half, and it's between 0 and 1. Okay, so to do that shrink, we need to put that c value underneath. Okay, so we want to put in x of x over a half cubed minus 16x over a half. Okay, so then we go ahead and you could simplify this so that this part here becomes 2x to the third minus, if you do the reciprocal here, you'd come up with, what, 32x. So this 16x becomes times, I don't know if you do it that way, the reciprocal. So that's where I'm getting 32x. And if you bring this cubed would be 1/8. And you flip it up, this is going to become 8x to the third minus 32x. Okay, so that's your vertical shrink by a half. Let's see if we can throw one more in here quick, so I don't make your video too long. So let's try f of x equals x squared minus x. Let's do a vertical stretch by 3. Okay, I have a thing for 3's. All right, so if that's the case, we're going to do f of x equals 3 times x squared minus x. Okay, chances are I like the verticals probably a little better than the horizontals, but we will see those somewhat here. All right, so 3x squared minus 3x, that would be the equation for your vertical stretch. Okay, done deal. Horizontal, stretch by 3. Okay, we would do something like, let's Just don't do 3 again. You're gonna get tired of 3s on your notes. How about 2? Let's mix it up a little bit. Okay, so if we do a horizontal stretch by 2, let's do x over 2, quantity squared, because it was x is here, we're putting in x over 2, okay, minus x over 2. Okay, so if we work that out a little bit, x squared over 4 minus x over 2, that would create a horizontal stretch by 2. Okay, maybe one last comment here. Sometimes you may encounter a function that's already showing some transformations. And I might ask you to list in order the transformations that are happening. So in other words, could you describe in words what's going on? All right, so let's say you take your favorite parent function, x squared, okay? And I have some transformations given, the following. 3 times the quantity, x minus 2 squared plus 5. Okay, and so I would ask you, could you tell me in words how this original parabola has been transformed? Okay, so there's a nice order that you should do. So you want to work inside out. So the first thing that you'd want to tell me is what this minus 2 is doing. So you would want to say that is a horizontal shift. Okay, you got to think which direction. Okay, that one's going to be to the right too. Okay, then you go from there to the front. Okay, so is there something going on in the front? Well, sure enough, that should be a vertical stretch by a factor of 3. Okay, and then lastly, you deal with what's on the outside. So in that case, you have another vertical shift. That one's going to be up 5. So that would be the correct order to describe the transformation of the parent function parabola into this one. Okay, I hope that went well, and that completes the second video for our transformations. Thanks for watching. Good luck.